Next bit referring to determine their nature. It's a really, really important phrase. You'll see it come up again and again and again. What it means is, you remember we were talking about stationary points and turning points yesterday, right? So we want to work out, well, what kind of stationary point is this? Which way does it turn, or does it do something else, as you'll look at later? Okay. So how do we find this? How do you determine whether something's, say, a maximum or a minimum? What do we do? Yeah, we want to check what happens to the derivative on either side. Okay? So here's what we're going to do. We want to draw up a table for ourselves. We're checking two stationary points, right? So before, when we were checking one stationary point, we said, look at some x values, look at the derivative at those x values, and I said, look, pick your stationary point, right? And then pick a point on either side of it, okay? So minus 1 on root 3, what is that? It's minus 1 over 1.7, which must be 0. I don't know, 0.7? Can someone tell me? Like decimal? What is it? 0.58. Okay, great. Now the reason why I want this decimal is because I need to pick a point to the left and to the right. Okay? So what's a nice easy point to the left of this? I could pick, now hold on, this is negative, sorry. So to the left, I could pick minus 1/2, or I could pick minus 1. That would do, right? I'm going to go with minus 1 because I don't like fractions a little bit. It's racist when you don't like different races. So what is it when you don't like fractions? I'm a fractionist? Numberist? Anyway, okay. Minus 1 is to the left. What's something to the right? 0 is to the right. Now, you've got to be careful here. Do you remember I mentioned it sort of very quickly yesterday that you can't go too far away, okay? Like, for example, if I put in 10 or 100, I would come up with problems, and here is why. This is one of the stationary points, and this is what I would have as a table if I was just testing this stationary point. But of course, I've got another stationary point that I'm testing, right? The next one over, okay? So therefore, I should actually make this table a bit longer. Does this make sense? Okay? And I should have 1 on root 3, which is the next stationary point there. Now this is approximately, we just said, 0.58, okay? So for instance, if I said, well there's minus 1, there's my stationary point. If I said 1 here, I would have gone past this stationary point already. So something different is going to happen with the derivative, which is going to give me a different result. So you may even like to mention, this is a stationary point, this is a stationary point, and these are the in-between values. So let's pick 1 on the end. That'll be nice and neat. Okay? Now, let's fill in these parts here because you already know them, right? At these locations, the derivative is equal to 0, because that's how we found those values, okay? So now you need to take these and pop them into your derivative equation, okay? 3x squared minus 1. 3x squared minus 1. So 3 times minus 1 squared is just 3. So 3 minus 1 is 2. Okay? At 0. 3 times 0 squared minus 1 is 0 minus 1. So minus 1. Sorry, make it a bit neater. Okay? And again, this is the great thing about this is why we spent so long looking at odd functions, right? Because I've picked a point opposite over here, right? This is actually not an odd function. This is an even function, right? 3x squared minus 1. The derivative is even. And so what derivative are you expecting over here? Exactly the same, right? Because I've picked them on opposite sides, right? So this is your f of x and this is your f of minus x, okay? So little tricks. This is why we spent so long on it early this year. So now that you've got your numbers, you draw little directional lines to indicate, well, what do these numbers mean? So a positive gradient means it's increasing, okay? And then this one is horizontal because it's 0, okay? And then this one is negative, right? So it's decreasing. So then another stationary point, and you're getting the idea, okay? And of course, this string of lines, right, which is really just us interpreting the sign of the derivative, it does kind of look like what you'd expect this to be, which we're going to graph in a second, okay? So why did I draw this table at all? Why did I do this for? I wanted to determine nature, determine which one's max, which one's a min. So I would say, therefore, this one here, the first one, is a maximum. Okay? So I would say there's a max turning point at, and then I provide the coordinate, okay? Minus 1 under 3, 2. Okay? And of course the other one is a minimum. Hooray, that's part A. Okay?